mind the key information. I gave you the definition for adjacent. You do need to understand what that means and identify a pair of adjacent angles. If it's an adjacent angle, you can underline or highlight. It shares a common vertex and side. They do not overlap. But the key thing is common side and vertex. Okay. So I'm going to recap some things and make sure you understand how to label, identify, name angles. So the first thing I need to remind you, and this was kind of talked about, was that if you mark an angle, you mark an angle with an arc. So if I want to mark angle APC, I would do a little curve in the interior of the angle. I need you to mark this angle. And we can name an angle by the 3 points on the angle with the vertex being in the middle. So I could say this is our angle symbol, the less than. I would never write the word angle in here. I'm not going to ask you to read the word angle. I'm asking you to read that symbol. Okay? So angle APC is also, and if once I put that number here in the interior, it's also angle 1. They are the same angle. One I'm naming with the number, one I'm naming with the points on the angle. Does that make sense? Okay, so another way, so since I've already marked this angle 1 with one arc, this is my second angle, and it's not congruent to that, so now I put 2 arcs. So add the 2 arcs to show how to distinguish the angle. Then I have this third angle here, so here I would have to put 3 arcs. By doing that, I'm showing that angle 1 is not congruent to angle 2 or 3. Are we okay here? All right, so I'm going to highlight just to make sure you can see the relationship. So angle 1 is from AP to C. The sides of angle 1 are AP and CP. Those are the sides that make the angle with the common vertex P. Now, the minute I go to angle 2, that is C. PD. Do y'all see how the yellow and the green are overlapping the sharing? Okay. So basically what I'm showing you right here, this was what we call a common or shared, side to an angle. That's your example of a common side. So if they're adjacent, they share a side. They have a common side. They are adjacent if they're next to each other and they have a common side, a shared side, or they're kind of like neighbors. So one of the examples you're going to write down, you're going to do this one with me. Angle 1 and angle 2 are adjacent. Now I abbreviate adjacent, ADJ, and then I put angles with apostrophe S, okay? That's one example of angle pairs. Does anyone see another pair, adjacent angles? Does anyone see another pair of adjacent angles? Yeah, 2 and 3. So you would write also angle 2 and angle 3, okay, are also adjacent angles. Okay. Do we understand adjacent? We're okay on that. That's the first skill to our angle pairs. All right, so if they're adjacent, they share a common side. Non-adjacents basically do not have a shared side. So look at your figure. Which angle pairs would be non-adjacent? Yeah, 1 and 3. Okay, your example would be angle 1 and angle 3 are non-adjacent. So there's your examples for adjacent and non-adjacent. Yes?
Like for the adjacent angles, that if don't overlap, don't 1 and 2 overlap.
1 and 2 overlap.
Where the yellow.
Oh, I say you would see the Are you seeing the overlap as I'm talking about APD? Is that where you're seeing the overlap?
Well, you're saying I like the wherever the shares.
This is shared. I showed that the colors overlap to show that they share this side. To not overlap means that they can't be on top of each other. So can't, like if I were to draw another angle here, this angle here overlaps this angle, like my blue angle overlaps my yellow angle. You see what I'm saying? Okay, all right. All right, so our first tab we're going to look at is complementary. It's at the bottom left. All right, complementary angles are two angles with a sum of 90 degrees. Okay, 90 degrees. They can be adjacent or non-adjacent. So another way to help you understand or recognize complementary, this C for complementary, I can turn into a 9 to get 90 degrees. Complementary have a sum of 90, and they can be adjacent or non-adjacent. Also, to identify complementary, you must see the box. Okay, you must see that box to identify complementary. So, because I have this box here in my example, what would I do to find the measure of angle x? I can say, yeah, x plus 15 equals 90 degrees, or I can say 90 minus 15 will give me my x, right? So what's the value of x? Now, you would just write that in the interior in between the two sides of the angle. Okay with complementary? All right, that's pretty simple. All right, let's go to the next one. Next one is supplementary. Supplementary are two angles with the sum of 180 degrees. Okay? Again, they can be adjacent or non-adjacent. To help you identify or recognize the relationship with supplementary, this S I could turn into an 8, 180 degrees. Okay? S can turn into 8, C can turn into a 9. So 180 degrees. So in this example, angle A and angle B, are they adjacent or non-adjacent? Non-adjacent, okay? The other one we had was adjacent, okay? So we want to find the measure of x. If they're supplementary, what would you need to do to find the measure of x? Yeah, the 180 minus the 120. So x would be our 60 degrees, okay? So all we're doing is finding the complement or the supplement to the angle pair once given one of the angles. All right, so that's supplementary. Next angle pair, linear pair. Okay, linear pair. Now, linear pairs have to be, these are two adjacent. They have to be adjacent to be a linear pair. Okay? Two adjacent angles whose non-common sides form, and I'm just going to abbreviate opposite OPP, opposite rays. Basically, they form, if it's an opposite ray, it has to form a straight line. Okay? They form a line when it's a linear pair. And in linear, you see the word line. So the minute I see a line and I have a common vertex, I'm basically creating linear pairs. Linear pairs are, and this is my abbreviation for supplementary, SUPP, meaning they equal 180. Okay? Linear pairs are supplementary, so they have a sum of 180 degrees. Also, in a linear pair, you're always going to have basically what we call an obtuse angle and an acute angle. Always some type of combination of obtuse and acute. There is a special case. Anyone know the special case of a linear pair that's not obtuse and acute? Right, yeah, two right angles. If they're both 90, it would give you 180. Are we okay on that? All right, so if I know that this obtuse angle here is 120 and I want to find the value of x, I just take 180 from that. So the measure of x would be 68 degrees. All right, we're done. Okay? 68. Now, last angle pair. Vertical angles, okay? Vertical angles. understand vertical angles? They're formed by a pair of opposite rays. Okay, two pairs, meaning if I have two pairs of opposite ways, I'm basically going to create two intersecting lines. This is important. Basically, that's how I distinguish. The minute I see lines intersecting, I have vertical angles, always. When that happens, I want you to add this to this little figure right here. When that happens, some people think of a V because there's like a little V here. But when two lines intersect, automatically you have four angles. Okay? The relationship for vertical angles is that the angles that are opposite each other or across from each other, vertical angles are always, this is your symbol for congruent, are always congruent. So what number is opposite 1? Angle 1. 3. So I would mark 1 and 3 with an arc because those will always be the same value. Whatever 1 is, 3 would be. And then what's my other pair of opposite angles? So this would be 2 arcs. Okay, so 2 and 4 would be congruent. So the beauty about vertical angles is if you know the relationship that they're congruent, there's no math really to work out. Because if you look at our example here, isn't this angle x or this x measure opposite across from 72? So we already know x is 72 degrees, and we're done. Okay? So we're going to keep going because we got to 12:10 here. I know the bell rings off a little bit. This is what goes in the foldable. We just did that. What we're going to do now is the extra examples. The examples that I asked you to copy down, that's more like your assessment-like questions, your test questions, okay? So go to your new page where you wrote this down. Let's see if we really understand first supplementary and complementary. So let's look at this figure. Would 4 and 5 be supplementary? 4 and 5. Supplementary has to equal what? 180. So what other angle equals 180? So close. Yes, 4 and 3 would work. So here's, if it's 180, and I might want you to add this here. Another example of 180 degrees is a straight angle. Okay, that means it makes a straight line. So it would make a straight line somewhere to make a linear pair, a supplementary relationship. So this first one here, 4 and 5, this is no. What about 2 and 3? Are they complementary? Are 2 and 3 complementary angles? No, I don't know that. This would be no. What do I need to see for it to be complementary? A box. All right. So what about 4 and 3? Would they be supplementary? Yeah. So this is yes. And then 2 and 1. Are they complementary? Yes. Okay. So can we identify? And you're going to see it like that too. It's going to be several lines, and you have to identify which adjacent angles are complementary or supplementary. All right. So let's get into application. Okay. Now we're going to take what we know about the angle pair and apply it algebraically. I'm going to skip one real quick. Didn't I do this twice? I thought I did. Okay. All right, so I'll just do this. Scroll this down. Bring this down. Oh, the M means measure. Okay, lowercase m means measure. All right, so on this first one, this m right here means measure of angle 1 is this expression 4x minus 2. So what you're going to do, the way you get partial credit, again, label the given information. Here's angle 1. In the interior, I'm going to write 4x minus 2 because that's the measure of that angle. Then they tell us that the measure of angle UVT, okay? So UVT, that is your whole angle. Does everyone see that? Okay? If I'm talking about the whole, usually I put an arc on the outside. The whole angle is the 6x plus 10. I always start with drawing and labeling the given. We don't need to draw it, it's already given to us. All right, angle 2. Angle 2 here has the measure of 20 degrees. They want us to find x, find the measure of angle 1, and then classify it. So, are these angles adjacent or non-adjacent? Adjacent. So whenever you see adjacent, you do addition. A for adjacent, A for addition. So I should know that, and we're going to simplify this. Angle 1 plus angle 2, right, equals the whole angle, which is angle UBT. So now I can go to just substituting, adding the angles together, the adjacent angles, which is basically our 4x minus 2 plus the 20 equals 6x plus 10. Questions on that step, what I did there? All right, now we're just solving for x. So what we need to do here, I can simplify here. So we got 4x, what is it, plus 18 equals 6x plus 10. Now we're solving for x. So see if you can solve for x. We've got to get that first. Subtract the 4x. 18. 2x plus 10. X is what? Yeah, x is 4. We good? Okay. So, we got 4 is x. So now all we need to do to find angle 1 is we're going to plug it back into 4x minus 2. So 4 times 4 minus 2. So what is the measure of angle 1? Yeah. So this is the degrees, right? What, yeah. Finishing the notes is your homework. Yeah. You don't have to worry about that yet. Yeah, finishing the notes is your homework.